Make x the subject of the formula in each of the following cases. So here, the two things that are stopping x from being the subject are this 3 and the a, so we need to get rid of those from this side and move them over to the other side. So to do that, we'll first of all begin by subtracting that a from that side so that it appears over here. So that will just give us 3x equals y plus z minus a. We also need to get rid of the 3. So to do that, that's currently 3 multiplied by x. So if I divide by 3, that will see that disappear, and I'll also divide the other side by 3. That will cause the 3 to cancel out. So I'm just left with x is y plus z minus a all over 3. This time, the x is hidden in a bracket here. So there's a couple of ways of doing this. You could either choose to expand the brackets and then move everything over, or you could just choose to get rid of this a off the front here first of all. And either of those would be absolutely fine. I'm going to expand the brackets and then move it over, I think. So we've got ax plus ab equals c. And then I only want this term here with the x in it, so I'm going to kick off the minus ab. So that gives me ax equals c minus ab. And then I need to get rid of this a term from this side, so I'll divide through by a. And that will go to leave myself with x equals c minus ab all over a. Make x the subject of the formula in each of the following cases. It's just a bit more work to do with some of these here. Now, what's stopping x from being on its own here? Well, just this a term. So all I need to do is get rid of that a term in effect. So to do that, we'll multiply both sides by a, because that will cancel out. And I'm also going to have to multiply everything over here by a too. And that will refer to both of these. And I could have merged them a minute ago, but I've not. So I'm going to have to multiply both of those terms by a. That will get rid of the a from this side to leave me with x equals 1 lots of a is just a. And then I've got, if I multiply this fraction by a, I just get a squared over b. And there's not much else to do with that. You could merge these two to tidy them up, which I think we'll do now, just because it looks a bit better. So if we want to put these both over a common fraction, they'd need to go both over b. So to achieve that, I need to multiply the top and bottom of this fraction in effect by b. So if I consider it as being a over 1, if I multiply the top and bottom of that by b, I'd have ab over b plus a squared over b. So when I tidy that up into a single fraction, I just get a squared plus ab over b, which looks a lot better than it did a minute ago. Okay, with this one we've just got some extra terms. There's lots of different ways you could approach this. So I need to find this x term here. So the things I need to get rid of are this and this. Now, you could merge these first into a single fraction, or you could start by removing one of these terms off the bottom and then getting them up here. I'm going to do this just by getting rid of this y term first, without merging those. So I'm going to start by multiplying both sides by y, which will mean, since I haven't merged these two, I'll have to multiply both of those by y too. So I'll get x plus y, because I've cancelled out that one there, will equal y squared, which is still over a, and I've got ay, which is still over y. Now, I'm aware of the fact that those would cancel, but I'm not going to do that yet. I suspect I might need that in a minute. So now I just need to remove the y term from this side. So we'll subtract that. So I've got x equals all this lot again, y squared over a plus ay over y minus y. But since we're dealing with fractions here, we'll write that as y over 1, so that we can merge these a little bit more easily. In theory, you've kind of answered the question, but it just looks a bit untidy and need to merge them as a single fraction. So common denominator will be ay, because they'll go into ay on the bottom here. So to achieve that, I'd have to multiply this fraction top and bottom by y. So I'd have y cubed over ay. To achieve that with this one, I'd have to multiply top and bottom by a. So I'd have a squared y over ay. And with the final bit, I'd need to multiply top and bottom by ay. So I'd have ay squared over ay. Now they can all be merged into a single fraction. So that would just be y cubed plus a squared y minus a squared y minus ay squared, over ay, which is nearly finished. There's a y term here which is common to all parts above, so could hence be factorized by pulling out the y. So I can cancel that down to leave myself with x equals y squared plus a squared minus a, and that's all over a. Make x the subject of the formula in each of the following cases. Should be noting straight away here that x appears twice, which tells you you're going to need to factorize it at some point to turn 2x's into 1. The first thing to do though is to lump them all together on the same side, which is what we're going to set about doing. Easiest way to do this, probably to expand the brackets, otherwise it could get a bit complicated. So we'll expand these and we'll get ax plus ay equals bx plus by. And now I need all of the x terms on the same side, so I'm going to shift that bx over. And now I've got ax minus bx, and I'll take this ay away in one move here. So I've got ax and then I've got a minus bx. I've got rid of that from that side, and now I've got by minus ay. So I've got all the things that I want on one side, which is the x terms, and now I'm just going to factorize that. So that will nicely turn 2x's into 1. So that'll be x brackets a minus b, and that is by minus ay, which could itself be factorized if you wanted to. So now I just need to get rid of this bracket, this a minus b. So to do that, I'm going to divide both sides by a minus b. And if I do that, that will cancel to leave myself with x equals, I'm going to factorize that now on top, so that'll be y lots of b minus a all over a minus b. So again, we've got 2x's in this situation. I need to first of all get rid of this fraction, get rid of the bottom half of this before I can deal with this. So I need to multiply both sides by x minus a. When I do that, I could write this with brackets, but I'm going to just expand them straight away here. So I'll get yx minus ay. I've already cancelled out the bottom half of that fraction by multiplying, so I just got x plus a left over here. Now I need to put all of the x terms on the same side, so I'm going to bring them over to this side, I think. So a couple of things, I need to subtract the x term, which I also need to do from over here. And then I need to add the ay to position that onto this side. So that will remove those two. It'll leave myself with yx minus x on this side, and it'll leave myself with a plus ay on the other side. Factorizing to turn 2x's into 1 will leave me with x brackets y minus 1. and just this lot on the right hand side, which you could factorize if you wanted to, into a brackets 1 plus y. Now what I need to do is remove the divide, and to do that I'm just going to now all I need to do is to remove this bracket by division, so divide both sides by y minus 1. And when I do that, I get x equals a brackets 1 plus y over y minus 1. Make x the subject of the formula in each of the following cases. So I need to find this x term here. I could multiply everything by x straight away, in which case I'd have to multiply this term by x and this one. But it might be easiest to take away that a straight away here. So subtracting the a from both sides, it gives y over x equals b minus a, and then removal of the x by multiplication will leave us with just a y on the left hand side, and then on the other side we're going to have x lots of b minus a. Notice that it didn't expand it automatically there, because I've actually now left the x term on its own. So the only thing that's left to do is to remove the brackets by division by b minus a. So that will leave us with what we wanted, which is the x term as the subject, and x therefore is y over b minus a. It's a classic misconception case here. We need to find the x term, and you might think the logical first thing to do is to square everything here, but just be aware that if you do that, then you don't end up with x plus 9 equals y squared, and that's because if you square this, i.e. multiply it by itself, it does not give you that at any point. So let's do this properly. Before we square anything, we need to be adding that 3 to the other side, make our life nice and easy. So that will just leave us with root x equals y plus 3. And now if we square both sides, that will leave us with x equals y plus 3 all squared. Again, we need to make x subject to the formula here, and there's lots of things stopping it from being on its own, but I can just move this lump here, this one, y squared over b squared, by just adding that to both sides straight away. So let's do that, and that will remove it from here and leave us with just the x squared that we want over a squared, and that will equal 4 lots of 4 added to y squared over b squared. Probably need to merge these here because we're about to multiply everything by a squared. You don't have to. In fact, let's not. Let's just get rid of that a squared by multiplication here. By multiplying everything by a squared, I'm going to have to multiply both of them since I've not merged them though. And that will give us just the x squared term. And then we've got 4 lots of a squared. And if I multiply this by a squared, I get a squared y squared over b squared. Now, from here, this is all looking a little bit untidy. So we need to merge them. So let's merge these. Then both going to need to go over b squared, so the only way to achieve that is to multiply top and bottom of this by b squared. So we'll have x squared equals 4a squared b squared, and that will now put it all over b squared, and I'm adding to that a squared y squared, and that is also over b squared. So I can merge those two together. So I've got 4a squared b squared plus a squared y squared over b squared. So now all I need to do is remove the squared term here, and to do that I'm just going to square root both sides. So little note, just going to root both sides so that I end up with x equals, and bear in mind there's going to be two answers to the square root, so it'll be plus or minus the square root of, and then all this lot, 4 a squared b squared plus a squared y squared over b squared.